Hi, Miss Youngblood here. We're going to do lesson 3.1b, representing proportional relationships with a graph. A proportional relationship, as we covered in 3.1a, is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. The graph will show the relationship between the weight of an object on the moon and its weight on Earth. We are then going to write an equation for this relationship. So let's move this up so that we can have better access to it. And we are going to 1, 2, 3, 4, 5. Let's change the color. Graph out some weights for the weight of objects on Earth and on the moon. Now, I did not know the difference between the weight of an object on the Earth and the weight of an object on the moon. I had to ask Mr. Youngblood, who knows these things. So, down here we have our Earth weight. Up here we have our moon weight. Now, let's count out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so our weight on Earth, which is right here, our first one is 6 pounds. Our second one is 9 pounds. Third one is 12, 15, and then 18. So now let's find out our weight on the moon. Our first one is right here, which is 1. And our second one is at 9, and it's about halfway in between. And yes, I know my lines aren't perfectly straight, but it's 1.5. And our third one, our 12, is at 2. And 15 looks to be about 1.5 and 2.5, sorry, 2.5, and 18 is at 3. Now we're going to find the constant of proportionality. I am going to use this number right here, and we are going to first write it as a ratio. So if we write this as a ratio, remember we're writing the weight of an object on the moon, so our moon weight is 1 to our weight of an object on the Earth, so it's 1/6. Now we turn around and we need to turn that into a fraction. Remember, because it makes it so much easier to work with it in an equation, because our next step is to write an equation. So remember, our equation is y equals kx, and our 1/6 equals k, so we can plug that in for k. And our weight on the Earth is our x, and our weight on the moon is our y. So now I can pick another pair of numbers, say this one, and I can write this as an equation. So my y in this equation is going to be 3 equals my k is 1/6 multiplied by 18. Do I need to solve this equation? No, it's not asking us to. I just need to write it out, and we've done that. So now I'm going to clear the board and go to the next page, because we're going to start another one for you, okay? So we're going to clear this and go down. So now we are going to graph and show the relationship between the amount of time that a backpacker hikes and the distance traveled. and we're going to write an equation for the relationship. So I'm just going to graph. I'm just going to mark some points on here. All right. And let's count. 1, 2, 3. So this is 3 hours. 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7. Wow. 8, 9, and 10. So now we need to write our equation. So we can use our first point. But first of all, let's get our pairs. So time and distance. So our first pair is 3 and 3. Our second pair is 5 and 5. And then we have 7 and 7. And you know what I am going to do? I'm going to fix this one because I want it to be proportional, not disproportional. So I'm going to fix that one right there. And this is going to be at 9. I know that totally messed you guys up. And that's okay. Because see, I even make mistakes. All right. So we have our table. We can use first pair for our k equals 3 to 3 ratio, which if we write it as a fraction is 3 over 3. And remember our equation is y equals kx. So our y, we can use, which ordered pair? Let's use 7. Seven equals 3 over 3 times 7. And I hope that you guys all realize that a 3 over 3 or a 7 over 7 or a 9 over 9, if the same number is on the numerator and the denominator, it equals 1. So 1 times 7 is going to equal 7. So we know that's right. And there we go. 3.1b. Enjoy.